Good day, everyone. Today we will be discussing an exciting topic in mathematics, which is trigonometry. So this topic will help us understand the relationships between angles and sides of triangles and how these concepts are applied in real-life situations. I will not be discussing this alone as I am joined by my partner, Shimi Konsad. Together, we will guide you step by step through the concepts, examples, and problem-solving techniques in trigonometry. Without further ado, let us begin. For question number 1, evaluate tangent 240 degrees. A. 1, B. Square root of 2, C. Square root of 3, D. Square root of 4. What do you think? To solve, step 1, identify the quadrant 240 degrees lies in quadrant 3, where both sine and cosine are negative but tangent is positive. So we first determine the sign using quadrant rules, or ASTC. Step 2, find reference angle. So 240 degrees minus 180 degrees is equal to 60 degrees. We reduce the angle to its reference angle to simplify computation. Step 3, evaluate tangent. So tangent 60 degrees is equal to square root of 3. So since quadrant 3 makes tangent positive, result stays square root of 3. So using special angles allows quick evaluation without a calculator. So the final answer is square root of 3. For the second question, what is the exact value of cosine negative 630 degrees? A. 1, B. 0, C. 2, 3, D. 3. To solve, step 1, use even identity. So cosine negative theta is equal to cosine theta. So cosine negative 630 degrees is equal to cosine 630 degrees. So cosine is even, so the negative angle is removed. So step 2, reduce angle. 630 degrees is minus 360 degrees is equal to 270 degrees. So we use coterminal angles to bring it within 0 degrees to 360 degrees. Now, step 3, evaluate cosine. So cosine 270 degrees is equal to 0. So at 270 degrees, the point lies on the y-axis, so cosine is 0. For question number 278, identify the exact value of cosecant negative 5 pi over 6. Is it A, negative 1, B, negative 2, C, 1, D, 2? So let's check if your answer is correct. So step 1, convert using sign symmetry. Sine negative theta is equal to negative sine theta. So sine negative 5 pi over 6 is equal to negative sine 5 pi over 6. So sine is odd, so the sign changes. Step 2, evaluate reference angle. So sine 5 pi over 6 is equal to 1/2. So sine negative 5 pi over 6 is equal to negative 1/2. We use the unit circle special angle. Step 3, apply reciprocal identity. So cosecant theta is equal to 1 over sine theta. So cosecant negative 5 pi over 6 is equal to 1 divided by negative 1/2 is equals to negative 2. So cosecant is just the reciprocal of sine. So the final answer is negative 2. For question 279, simplify sine pi over 4. So is it A, square root of 2 over 2, B, negative square root of 2 over 2, C, negative square root of 2 over 3, D, negative square root of 2 over 3. To solve, step 1, recognize special angle. Pi over 4 is equal to 45 degrees. Converting radians helps identify known values. So step 2, apply unit circle value. So sine 45 degrees is equal to square root of 2 over 2. So this is a memorized special angle result. Therefore, the final answer is square root of 2 over 2. For question 280, evaluate cosine 270 degrees. A, 0, B, 1, C, 2, 3, square root of 2. To solve, let's go step by step. What is cosine 270 degrees? So, which part do we evaluate first? So, it's always the inner function. So, what is cosine 270 degrees? So, that equals to 0. Now, we substitute cosine 0. So, what is cosine 0? So, cosine 0 is equal to 1. Therefore, the final answer is 1 because we evaluated inside out. For question 281, evaluate tan cosine negative 11 pi over 2. A, 1, B, 2, C, 0, D, 5. So to solve, let's break it down. What is tan cosine negative 11 pi over 2? So the first question, can we simplify the cosine input? Yes. Cosine is even. So cosine negative theta is equal to cosine theta. So now we have cosine 11 pi over 2. Next, is that within one rotation? No. Subtract multiples of 2 pi, we get 3 pi over 2. Now, what is cosine 3 pi over 2? That equals 0. Now, substitute into tangent. So, tangent 0. Now, what is tangent 0? So, that equals to 0 as well. Therefore, the final answer is 0. Question 282. Evaluate tan sine 300 degrees. A, negative square root of 1 over 2. B, negative square root of 3 over 2. C, negative square root of 3 over 3. D, negative square root of 3 over 5. To solve, let's analyze what is tangent sine 300 degrees. What is sine 300 degrees? So 300 degrees is in quadrant 4, where sine is negative. So in reference angle, so the reference angle is 60 degrees, so we get negative square root of 3 over 2. Now substitute tangent negative square root of 3 over 2. Is this a special angle? No, it's not one of the standard angles. So the answer stays as tangent negative square root of 3 over 2 because it cannot be simplified further. Question number 283. Use the fundamental identities to simplify cosine theta cotangent theta over 1 minus sine squared theta. A, cosine theta, B, cotangent theta, C, cosecant theta, or D, sine theta. To solve, let's simplify. What identity can we use first? So we see 1 minus sine squared theta. Does that look familiar? Yes, that equals cosine squared theta. Now, rewrite cotangent theta. What is cotangent theta? That's cosine theta over sine theta. Now, substitute everything. What cancels out? After simplifying, everything reduces to 1 over sine theta. And what is 1 over sine theta? That is cosecant theta. Therefore, the final answer is cosecant theta. So, using the identities and simplification. Let's proceed to the question 200 in 284. So, which of the following is equal to secant x minus cosine x? A, sine x tan x. B, sine x cotangent x. C, secant x tangent x, or cosecant x tangent x. To solve, let's rewrite what is secant x. That's 1 over cosine x. Now, we have 1 over cosine x minus cosine x. How do we combine them? Use a common denominator. We get 1 minus cosine squared x over cosine x. Now, what is 1 minus cosine squared x? That equals to sine squared x. So now we have sine squared x over cosine x. Break it apart. That would be sine x times sine x over cosine x. And what is sine x over cosine x? That's tangent x. Therefore, the final answer is sine x tangent x. For question 286, Simplify cosecant raised to 4x minus cotangent raised to 4x using identities. A. Cosecant squared x plus cotangent squared x. B. Cosecant x plus cotangent squared x. C. Cosecant squared x plus cotangent x. Or D. Cosecant squared x minus cotangent squared x. To solve, first, let's factor. Does this look like a pattern? Yes, so difference of squares. So we rewrite it as cosecant squared x minus cotangent squared x times the quantity of cosecant squared x plus cotangent squared x. Now, what is cosecant squared x minus cotangent squared x? That equals to 1. So, we're left with cosecant squared x plus cotangent squared x. Therefore, the final answer is cosecant squared x plus cotangent squared x. For question 287, use trigonometric identities to simplify sine x plus cosine x times the quantity of tangent x plus cotangent x. A. Sine x plus cosecant x. B. Secant x plus cosine x. C. Tan x plus cosecant x. Or D. Secant x plus cosecant x. To solve, let's expand step by step. First, what are tangent and cotangent in sine over cosine? So tangent is equal to sine over cosine. Cotangent is equal to cosine over sine. Now substitute and multiply. So after simplifying, terms cancel nicely. So the final question is, what do we get after simplification? So it becomes secant x plus cosecant x. Therefore, the final answer is secant x plus cosecant x. Let's proceed with question 288. Which is a quotient identity? A. Secant theta is equal to sine theta over cosine theta. B. Cosecant theta is equal to cosine theta over sine theta. C. Tangent theta is equal to sine theta over cosine theta. Letter D. Secant theta is equal to tangent theta over cosine theta. To solve, let's start with definitions. From the unit circle, sine theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. Next, form the ratio. Sine theta over cosine theta is equal to opposite over hypotenuse over adjacent over hypotenuse. Next, simplify. It will be opposite over adjacent equals tan theta. Therefore, the final answer is tan theta is equal to sine theta over cosine theta. Let's proceed with question 289. A right triangle always has an angle of A. 90 degrees, B. 80 degrees, C. 70 degrees, or D. 60 degrees. So what do you think? What makes a triangle a right triangle? Of course, a right angle measures 90 degrees. Therefore, the final answer is 90 degrees. Let's proceed to question 290. The total measure of the angles of an oblique triangle is A. 90 degrees, B. 180 degrees, C. 270 degrees, or letter D. 360 degrees. So the sum of the interior angles of any triangle is 180 degrees, regardless of the triangle type. All angles add up to 180 degrees. Therefore, the final answer is 180 degrees. Question number 291. Which of the following triangle can never have a 90 degrees angle? A. Scalene, B. Equilateral, C. Isosceles, D. Oblique. Now let's first recall the definition. An equilateral triangle has all sides equal and all angles equal. Next, identify angle measure. So each angle is equal to 60 degrees. So since all angles are 60 degrees, it cannot have a 90 degrees angle. Therefore, the answer is equilateral. Let's proceed with question 292. A tree leans 7 degrees to the vertical at a point 40 feet from the tree on the side of the closest to the lean. The angle of elevation to the top of the tree is 24 degrees. Find the height of the tree. A. 18.01 feet. B. 20 feet. C. 17.01 feet. Or letter D. 19 feet. To solve, first, visualize the situation. The tree is leaning, not straight up. That means the actual length of the tree is not equal to its vertical height. So the top of the tree is shifted horizontally. Now, what are we solving for? So, we are solving for the height of the tree, the vertical height, not slanted length. So, we are given distance from observer to tree base, that's 40 feet, angle of elevation, which is 24 degrees. Tree leans 7 degrees toward the observer. So, if the tree leans toward the observer, is the top farther or closer? Closer. So, we must adjust the horizontal distance. So, let's represent the tree using variables. So, let's assign L, length of the tree, because the tree is tilted. Now, why cosine for height? Because cosine represents the adjacent side or the vertical component. So why sine for horizontal? Because sine represents the opposite side or the horizontal shift. So originally, the observer is 40 feet from the base, but the top moved closer due to the lean. So the new horizontal distance becomes 40 L sine 7 degrees. Now, we use the angle of elevation, 24 degrees. Now, which trigonometric ratio relates height and horizontal distance? That is tangent. Now, we solve for L. After simplifying and solving, we get approximately 17.07 feet. Is this already the height? Not yet. So, this is the length of the tree, not its vertical height. Since the tree is tilted, we take only the vertical component, which is the answer is, so what could be the correct choice? So the answer is 17.01 feet. For numbers 293 to 294, refer to the problem below. So two markers A and B, 58 feet apart, are on the same side of a river. A third marker is located across the river at point C. A surveyor determines that CAB is equal to 68 degrees and ABC is equal to 52 degrees. Now, in 293, what is the distance between points A and C? A, 25.10 feet. B, 52.78 feet. C, 13 feet, or D, 60.5 feet. So, to solve, first is use law of sines. A over sine A is equal to B over sine B. Next, substitute values. Sine AC over 52 degrees is equal to the given side over sine 60 degrees. Next, solve for AC, cross multiply and compute. So AC is equal to sine 52 degrees over sine 60 degrees times the given side. So therefore, after computing, the answer is AC is approximately 52.78 feet. So for question 294, what is the distance across the river? A, 31.66 feet. B, 43.5 feet. C, 48.94 feet. Or letter D, 50.21 feet. So, let's start with the given. Hypotenuse is equal to 98 feet. Angle is equal to 30 degrees. Now, find opposite side or the river width. First step, use sine formula. Sine theta is equal to opposite over hypotenuse. Now, substitute values. Sine 30 degrees is equal to x over 98. Solve for x. X is equal to 98 over sine 30 degrees. So, sine 30 degrees is equal to 0.5. So, x is equal to 98 times 0.5. Therefore, x is equal to 49 or approximately 49. Therefore, the final answer is 48.94 feet. For numbers 295 to 297, refer to the given below. In triangle ABC, A equals 14 cm, B is equal to 9 cm, and C is equal to 6 cm. So, number 295, what is the measure of angle A? A, 145 degrees, B, 167 degrees, C, 137 degrees, or letter D, 120 degrees. To solve, the given sides, A equals 20, B equals 25, C equals 35. Now find angle A. So first step, law of cosines. A squared equals B squared plus C squared minus 2B cosine A. Substitute values. 20 squared is equal to 25 squared plus 35 squared minus 2 times 25 times 35 cosine A. Now compute squares. 400 is equal to 625 plus 1225 minus 1750 cosine A. That's 400 is equal to 1850 minus 1750 cosine A. Solve for cosine A, that is 400 minus 1850 is equal to negative 1750 cosine A. That's negative 1450 is equal to negative 1750 cosine A. So cosine A is equal to 1450 over 1750. Therefore, the final answer is 137 degrees. For question 296, find the measure of angle B. A, 23 degrees, B, 24 degrees, C, 25 degrees, or D, 26 degrees. So to solve, first, the triangle sum rule, A plus B plus C is equal to 180 degrees. So substitute values. So A is equal to 137 degrees plus B plus 17 degrees is equal to 180 degrees. Now solve. B is equal to 180 degrees minus 154 degrees. Therefore, B is 26 degrees. Therefore, the final answer is 26 degrees. Now, let's proceed with question number 297. What is the measure of angle C? A, 16 degrees, B, 17 degrees, C, 18 degrees, or D, 19 degrees. Since we have the value of A and B, we use the sum rule. So C is equal to 180 degrees minus the quantity of 137 degrees plus 26 degrees. So compute. C is equal to 180 degrees minus 160 degrees. That's 17 degrees. Therefore, the final answer is 17 degrees. Question number 298. Calculate side B. A, 4.43, B, 4.50, C, 4.91, or D, 4.97. To solve, first, use the law of sines. A over sine A is equal to B over sine B. First, find the missing angle. So A is equal to 180 degrees minus the quantity of 47 degrees plus 63 degrees. That's equal to 70 degrees. So side 5.4 is opposite 63 degrees. And side B is opposite 47 degrees. So B is equal to 5.4 sine 47 degrees over sine 63 degrees. So B is equal to 5.4 times 0.731 over 0.891. Approximately 5.4 times 0.821. Therefore, the answer is 4.43. To proceed, let's have question 299. Calculate side C. A, 10.8, B. 11.8, C. 13.8, or D. 15.8. So the angles 30 degrees plus 100 degrees plus 50 degrees is equal to 180 degrees. Side 8 is opposite 30 degrees and C is opposite 100 degrees. Therefore, C is equal to 8 sine 100 degrees over sine 30 degrees. C is equal to 8 times 0.985 over 0.5 equals 8.1.97. So 8.8 times 1.97 is equal to 15.76. Therefore, the answer is approximately 15.8. For question 300, law of sines can be used to solve the following oblique triangle except A. Side angle angle, B. Angle side angle, C. Side side angle, or D. Angle angle angle. So law of sines works for side angle angle, angle side angle, side side angle. So but angle 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 has no side given, so you cannot find lengths. Therefore, the answer is angle angle angle. To proceed, I will give the virtual floor to Teacher Shem.
Good day, everyone. This is Shimi Ted, and I will continue to present the remaining questions for this trigonometry review session. Thus, have fun and enjoy learning. Question number 301. Simplify sine squared theta over cosine theta plus cosine squared theta over cosine theta. And here are the choices. Letter A, tangent theta. Letter B, sine theta. Letter C, secant theta. Letter D, cotangent theta. And the answer is letter C. And here are the steps. Step 1. Combine the fractions. Since both terms have the same denominator, which is cosine theta, we can add the numerators directly. From our original expression, which is sine squared theta over cosine theta plus cosine squared theta over cosine theta equals sine squared theta plus cosine squared theta over cosine theta. For our step 2, use the Pythagorean identity. Let's recall the fundamental trigonometric identity, which is the sine squared theta plus cosine squared theta is equals to 1. And if we substitute this into our expression, it gives us 1 over cosine theta. And for our step 3, apply the reciprocal identity. Since the reciprocal identity of 1 over cosine theta is equivalent to secant theta, therefore our answer is letter C. Question number 302. Simplify tangent x over sine x. And here are the choices. Letter A, tangent x. Letter B, sine x. Letter C, secant x. Letter D, cotangent x. And the answer is letter C. And here are the steps. Step 1. Use the quotient identity. We know that tangent x is equivalent to sine x over cosine x. And if we substitute this into the expression, and it gives us sine x over cosine x over sine x. For our step 2 is to simplify the fraction. Dividing by sine x is the same as multiplying by its reciprocal 1 over sine x. Therefore, sine x over cosine x is multiplied to 1 over sine x. Step 3 is cancel common terms. Since the sine x terms in the numerator and denominator are cancelled out, leaving us with 1 over cosine x. Our step 4 is to apply the reciprocal identity. Since the reciprocal identity of 1 over cosine x is equal to secant x. Question number 303. Simplify sine y plus sine y cotangent squared y. And here are the choices. Letter A, secant y. Letter B, cosine y. Letter C, sine y. Letter D, cosecant y. And the answer is letter D. And here are the steps. Step 1. Factor out the common term. Both terms in the expression contain sine y, so we can factor it out. From sine y plus sine y cotangent squared y is equals to sine y times the quantity of 1 plus cotangent squared y. Second step is to use a Pythagorean identity. Recall the identity 1 plus cotangent squared y is equal to cosecant squared y. And if we substitute this into the expression, we get sine y times the quantity of cosecant squared y. Step 3 is apply the reciprocal identity. Since cosecant y is equivalent to 1 over sine y, we can rewrite the expression as sine y times the quantity of 1 over sine squared y. Step 4 is to cancel out one side, y, from the numerator and denominator. Therefore, the remaining is 1 over sine y, which is equivalent to the reciprocal of cosecant y. Question number 304. Simplify cosine x plus sine x tangent x. And here are the choices. Letter A, secant x. Letter B, cosine x. Letter C, sine x. Letter D, cosecant x. And the answer is letter A. And here are the steps. Step 1, rewrite tangent in terms of sine and cosine. Therefore, we substitute tangent x equals sine x over cosine x, the quotient identity, into the expression. Cosine x plus sine x, the quotient identity, which is the sine x over cosine x, equals cosine x plus sine squared x over cosine x. Step 2 is find the common denominator. To add these terms, we multiply cosine x by cosine x over cosine x. So our new expression is cosine squared x over cosine x plus sine squared x over cosine x. Since they have the same denominator, we just simply add the numerator directly. Therefore, cosine squared x plus sine squared x over cosine x. Step 3 is to apply the Pythagorean and reciprocal identities. Using the identity cosine squared x plus sine squared x equals 1, the expression is simplified into 1 over cosine x. And finally, using the identity 1 over cosine x, we can get secant x. And that is our result. Question number 305. Simplify tangent squared t plus 1 over 1 plus cotangent squared t. And here are the choices. Letter A, tangent squared t. Letter B, cotangent squared t. Letter C, sine squared t. And letter D, secant squared t. And the answer is letter A. And here are the steps. First is apply Pythagorean identities. Let us recall the fundamental identities. First is the tangent squared plus 1 is equal to secant squared t, and 1 plus cotangent squared t is equal to cosecant squared t. And if we substitute these into the expression, we get secant squared t over cosecant squared t. Step 2 is use reciprocal identities. Next, we rewrite the functions in terms of sine and cosine. Since secant squared t is equal to 1 over cosine squared t, and cosecant squared t is equals to 1 over sine squared t. Now, our expression looks like this. 1 over cosine squared t over 1 over sine squared t. Step 3 is simplify the fraction. To divide by a fraction, we multiply by its reciprocal. 1 over cosine squared t times the reciprocal of 1 over sine squared t is sine squared t over 1 is equal to sine squared t over cosine squared t. Step 4 is to identify the final form. Using the quotient identity of tangent t, which is sine t over cosine t, we can conclude that sine squared t over cosine squared t is equivalent to tangent squared t. Question number 306. Simplify 1 minus cosine squared t over sine squared t. And here are the choices. Letter A, negative 2. Letter B, 2. Letter C, 1. Letter D, negative 1. And the answer is letter C. And here are the steps. Step 1. Apply the Pythagorean identity. Recall the identity sine squared plus cosine squared t is equal to 1. And if we subtract cosine squared t from both sides, we find that 1 minus cosine squared t is equal to sine squared t. And step 2 is to substitute and simplify. Now, let's replace the numerator in the original expression with sine squared t. So our expression looks like this: sine squared t over sine squared t. And if we divide these terms, we will get 1. Question number 307. Simplify tangent squared t over 1 minus secant squared t. And here are the choices. Letter A, negative 2. Letter B, 2. Letter C, 1. Letter D, negative 1. And the answer is letter D. And here are the steps. Step 1 is to identify the Pythagorean identity. Let's recall the identity involving tangent and secant. 1 plus tangent squared t is equivalent to secant squared t. Since we're looking for the tangent squared t, therefore we can transform this into 1 minus secant squared t equals negative tangent squared t. And step 2 is to substitute and simplify. Now, let's replace the denominator in the original fraction with negative tangent squared t. Therefore, our expression looks like this: tangent squared t over negative tangent squared t, which will result to negative 1. Question number 308. Simplify cosine squared t minus 1 over sine squared t minus 1. And here are the choices. Letter A, tangent squared t. Letter B, cotangent squared t. Letter C, sine squared t. Letter D, secant squared t. And the answer is letter A. And here are the steps. Step 1. Manipulate the Pythagorean identity. Starting with sine squared t plus cosine squared t equals 1, we can find expressions for both the numerator and the denominator. And for the numerator, let's subtract 1 and sine squared t from both sides. We get cosine squared t minus 1 equals negative sine squared t. And for the denominator, we subtract 1 and cosine squared t from both sides. It gives us sine squared t minus 1 equals negative cosine squared t. Step 2 is to substitute and simplify. Substitute those values that we obtained back into the original fraction. It's negative sine squared t over negative cosine squared t. And step 3 is to identify the final form. Since we recall that the quotient identity of tangent t is equivalent to sine t over cosine t, therefore, we get tangent squared t. Question number 309. Simplify secant t tangent t over tangent squared t plus 1. And here are the choices. Letter A, tangent t. Letter B, sine t. Letter C, cotangent t. Letter D, secant t. And the answer is letter B. And here are the steps. Step 1. Simplify the denominator. Let's recall the identity 1 plus tangent squared t is equal to secant squared t. Replacing the denominator will give us secant t tangent t over secant squared t. Step 2 is to reduce the fraction. We can cancel out 1 secant t from the top and the bottom, which gives us tangent t over secant t. Step 3 is to rewrite in terms of sine and cosine. Now, we substitute the basic identities. The quotient identity, which is tangent t, is equals to sine t over cosine t. And the secant t, which is equals to the reciprocal identity of 1 over cosine t. Our expression is now sine t over cosine t over 1 over cosine t. Step 4 is final simplification. When you multiply by the reciprocal of the bottom fraction, the cosine t terms cancel out. Sine t over cosine t times the reciprocal cosine t over 1, which will now have our answer sine t. Question number 310. Simplify cotangent t times the quantity of tangent t plus cotangent t. And here are the choices. Letter A, cosecant squared t. Letter B, sine squared t. Letter C, tangent squared t. Letter D, cotangent squared t. And the answer is letter A. And here are the steps. Step 1, distribute the cotangent. Multiply cotangent by both terms inside the parentheses. So cotangent t times the quantity of tangent t plus cotangent t times the quantity of cotangent t. So cotangent t, tangent t plus cotangent squared t. Step 2 is to use the reciprocal identity. Since cotangent t and tangent t are reciprocals, therefore, cotangent t is equals to 1 over tangent t. Their product is 1. So, 1 plus cotangent squared t. Step 3 is to apply the Pythagorean identity. Recall the fundamental identity, which is 1 plus cotangent squared t is equivalent to cosecant squared t. Question number 311. Simplify tangent t over tangent t plus cotangent t. And here are the choices. Letter A, cosecant squared t. Letter B, sine squared t. Letter C, tangent squared t. And letter D, cotangent squared t. And the answer is letter B. And here are the steps. Step 1, use quotient identities. Substitute tangent t equals sine t over cosine t and cotangent t, which is cosine t over sine t, into the expression. So, sine t over cosine t over sine t over cosine t plus cosine t over sine t. Step 2 is to simplify the denominator. To add the fractions in the denominator, find a common denominator. Here, the common denominator is sine t cosine t. So, sine t over cosine t plus cosine t over sine t is equals to sine squared t plus cosine squared t over sine t cosine t. That is the result when we cross multiply them. Since sine squared t plus cosine squared t is equal to 1, therefore the denominator becomes 1 over sine t cosine t. Step 3 is to combine and cancel. Now, substitute this back into the main fraction and multiply by the reciprocal of the denominator. Sine t over cosine t is multiplied to the reciprocal of 1 over sine t cosine t, which is the sine t cosine t over 1. The cosine t terms in the numerator and denominator cancel out. So, sine t times sine t equals sine squared t. Question number 312. Simplify cotangent t cosecant t times the quantity of secant squared t minus 1. Here are the choices. Letter A, tangent t. Letter B, sine t. Letter C, cotangent t. Letter D, secant t. And the answer is letter D. And here are the steps. Step 1, simplify the term in parentheses. Using the Pythagorean identity 1 plus tangent squared t, which is equals to secant squared t, we can say that secant squared t minus 1 is equals to tangent squared t. So, the original expression becomes cotangent t times cosecant t times tangent squared t. Step 2 is to rewrite in terms of sine and cosine. Now, we substitute the basic identities for each term. For cotangent t, it is equal to cosine t over sine t For cosecant t, it is equivalent to or equal to 1 over sine t. For tangent squared t, it is sine squared t over cosine squared t. If we plug this into the original expression, we can get cosine t over sine t times the quantity of 1 over sine t times the quantity of sine squared t over cosine squared t. Step 3 is to cancel common terms. Multiply the fractions and simplify, which is the cosine t times sine squared t over sine squared t times cosine squared t. As you can see, the sine squared t terms in the numerator and denominator can be cancelled out, so we have to cancel them. And 1 cosine t cancels from the top and bottom, and that leaves us with 1 over cosine t. For the step 4, we apply the final identity. Using the reciprocal identity of 1 over cosine t is equals to secant t, and that is our final result. Question number 313. Which of the following identities is cosecant x equals 1 over sine x? And here are the choices. Letter A, Fermat's identities. Letter B, Pythagorean identities. Letter C, quotient identities. Letter D, reciprocal identities. And the answer is letter D. These identities define the relationships between the basic trigonometric functions and their flipped counterparts. For example, here, as stated here, is that for cosecant x, we have 1 over sine x. For secant x, we have 1 over cosine x. For cotangent x equals 1 over tangent x. Question number 314. Which of the following identities is tangent x is equals to sine x over cosine x? And here are the choices. Letter A, Fermat's identities. Letter B, Pythagorean identities. Letter C, quotient identities. Letter D, reciprocal identities. And the answer is letter C, quotient identities. These identities express a trigonometric function as the ratio or quotient of two others. The two mains are, first is tangent x, which is equals to sine x over cosine x. Second one is cotangent x equals cosine x over sine x. Question number 315. Which of the following identities is sine squared u plus cosine squared u equals 1? And here are the choices. Letter A, Fermat's identities. Letter B, Pythagorean identities. Letter C, quotient identities. Letter D, reciprocal identities. And the answer is letter B, Pythagorean identities. So, the identity sine squared u plus cosine squared u equals 1 is the most fundamental of the Pythagorean identities. It is named this way because it is directly derived from the Pythagorean theorem, which is a squared plus b squared equals c squared when applied to a unit circle. For question numbers 316 to 318, find the amplitude of the given trigonometric functions. Question number 316. Y equals sine x. And here are the choices. Letter A, 2 pi. Letter B, 2. Letter C, 3 pi. Letter D, 3. And the answer is letter D. To find the amplitude of a trigonometric function in the form y equals a sine x, you look at the absolute value of the coefficient a. This value represents the height of the wave from its center line. And for the function y equals 3 sine x, the coefficient is 3, the amplitude is the absolute value of 3, so the answer is 3. Question number 317. Y equals sine 3x. And the answer is letter B. In the equation y equals sine 3x, the amplitude is determined by the number in front of the sine function. Since there is no visible number there, the coefficient is an implied 1. The 3 inside the parentheses affect the period of the wave, or how fast it repeats, but it doesn't change how high or low the wave goes. Question number 318. Y equals negative 2 cosine x. And here are the choices. Letter A, 0. Letter B, 1. Letter C, 2. Letter D, 3. And the answer is letter C. For the function y equals negative 2 cosine x, the amplitude is the absolute value of the coefficient in front of the cosine. Even though the number is negative, which flips the graph upside down, the amplitude, or the distance from the center to the peak, is always a positive value. Therefore, the amplitude equals the absolute value of negative 2, which is 2. For numbers 319 to 321, find the period. Question number 319. Y equals 3 sine x. And here are the choices. Letter A, 2 pi. Letter B, 2. Letter C, 3 pi. Letter D, 3. And the answer is letter A. To find the period of a sine function like y equals a sine bx, you use the formula period equals 2 pi over the absolute value of b. For the function y equals 3 sine x, the coefficient b, the number multiplying x, is 1, and using the formula period equals 2 pi over 1 is equals to 2 pi. Question number 320. Y equals sine 3x. And here are the choices. Letter A, 2 pi over 3. Letter B, 3 pi over 2. Letter C, 3 pi. Letter D, 2 pi. And the answer is letter A. To find the period for the function y equals sine 3x, we use the standard formula for sine and cosine waves, which is period equals 2 pi over the absolute value of b. In this case, the value of for b, the coefficient of x, is 3. Plugging that into our formula, period equals 2 pi over 3. Question number 321. Y equals negative 2 cosine x. And here are the choices. Letter A, 2 pi over 3. Letter B, 3 pi over 2. Letter C, 3 pi. Letter D, 2 pi. And the answer is letter D. For the function y equals negative 2 cosine x, we can find the period using the same formula, which is period equals 2 pi over the absolute value of b. In this equation, the negative 2 or the amplitude flips the graph and makes it taller, but it doesn't change how wide the cycles are. The coefficient b, the number with x, is 1. Therefore, the period equals 2 pi over 1 equals to 2 pi. For numbers 322 and 323, refer to this graph being shown. Question number 322. Which of the following is true about the graph? And here are the choices. Letter A, the amplitude is 1. Letter B, the period is equal to 3 pi over 2. Letter C, the graph shows a tangent function. Letter D, the graph has a vertical shift of 2 units. And the answer is letter A. Let's evaluate these options. For letter A, the amplitude is 1. It is true as noted above or as shown in the graph. Letter B, the period is equal to 3 pi over 2, which is false because the period is 2 pi. Letter C, the graph shows a tangent function. This is false because tangent graphs have vertical asymptotes and a different shape. Letter D, the graph has a vertical shift of 2 units. It is false because it is centered at y equals 0. Question number 323. Which of the following shows the equation of the graph? A, y equals sine x plus pi over 4. Letter B, y equals cosine times the quantity of x minus pi. Letter C, y equals sine times the quantity of x plus 3 pi. Letter D, y equals cosine times the quantity of x minus pi over 2. And the answer is letter D. We need an equation that matches the point pi over 2 and 1. So, let's test the options. For letter A, y equals sine times the quantity of pi over 2 plus pi over 4 equals sine 3 pi over 4, which is approximately 0.707, which is incorrect. For letter B, y equals cosine pi over 2 minus pi equals cosine negative pi over 2, which is equals to 0, which is also incorrect. Letter D is missing, so let's proceed to letter D, which is y equals cosine times the quantity of pi over 2 minus pi over 2 equals cosine 0, which is equivalent to 1, and also correct. Therefore, equation D correctly places the peak of a cosine wave, which normally happens at x equals 0, at x equals pi over 2 via a horizontal shift. For numbers 324 to 325, refer to the graph being shown below. For question 324, which of the following is the equation of the graph? And here are the choices. Letter A, y equals cosine times the quantity of x minus x over pi over 2 rather. Letter B, y equals sine times the quantity of x plus pi over 3. Letter C, y equals cosine times the quantity of x minus 3 pi over 2. Letter D, y equals sine times the quantity of x plus pi over 4. And the answer is letter B. First, let's look at the standard sine wave. A basic sine wave, which is y equals sine x, starts at the origin 0 and 0 and goes upward. Second is let's identify the shift. Looking at the graph being shown earlier, we look for an x-intercept where the curve is crossing the x-axis and heading upward. So in this graph, the point is at x equals 2 pi over 3 on the right, and would also occur at x equals pi over 3 if we follow the pattern to the left. The third one is to apply the phase shift formula. The general form is y equals sine times the quantity of x minus h, where h is the horizontal shift. If we use the point x equals negative pi over 3, we can get y equals sine times the quantity of x minus negative pi over 3. Y equals sine times the quantity of x plus pi over 3, which led to our answer, letter B. Question number 325. Which of the following is incorrect? And here are the choices. Letter A, the period is 2 pi. Letter B, the amplitude is 1 unit. Letter C, the midline is the x-axis. Letter D, the phase shift is equal to pi over 2. And the answer is letter D. Let's evaluate each statement based on our analysis. For letter A, the period is 2 pi. This is correct. As calculated above, which is 2 times 7 pi over 6 minus pi over 6, which equals to 2 pi. For letter B, the amplitude is 1 unit. This is also correct. As you can see in the graph, it oscillates 1 unit above and below the midline. For letter C, the midline is the x-axis. This is correct. The wave is perfectly centered on y equals 0. For letter D, the phase shift is equal to pi over 2. This is incorrect because the phase shift or the horizontal displacement from a standard starting point is either 2 pi over 3 for a standard sine or negative pi over 3, but definitely not pi over 2.